suppose you do a problem in dilutions, so you calculate what you have to dilute, and you find out that it calls for diluting 20 milliliters of red food coloring to a final volume of 250 milliliters. How would you do that? Well, you need to go back to your trusty volumetric pipette. This is our 20 milliliter volumetric pipette. So we're going to draw 20 milliliters of the red food coloring into this pipette, and then we're going to transfer it to a volumetric flask. And a volumetric flask is a flask that is of known volume. This one is 250 milliliters, and there's a little line that's scribed on it, just like on the volumetric pipette. And once again, you fill the liquid all the way up to even, so that the bottom of the meniscus is even with the liquid, with the line here. All right, so let's do that. First, we need to draw 20 milliliters of the red food coloring into the burette and into the pipette. And again, use good pipetting technique. And not quite enough.
Hold on.
So you draw the red liquid all the way up so that it's even above the line, excuse me, not even with the line, above the line, and then getting your eye down level with the line that's marked on the volumetric pipette. Allow it to drain down. There. And then transfer to, so we're going to transfer now to our volumetric flask. So again, the problem called for diluting 20 milliliters of the red solution to a final volume of 250 milliliters. So we are drawing our 20 milliliters of the red solution and transferring it to the volumetric flask using a volumetric pipette. Recall that good pipetting means that you don't blow out the tip. You allow it to drain, allow gravity to pull the last little bits out, and if there's a drop hanging at the end of the pipette, you can go ahead and touch the pipette to the side, and you can see that there is a little bit of fluid left in this pipette, and that's supposed to be there. That's how it works. All right, so now we have our volumetric flask with our 20 milliliters of red liquid, and we're going to dilute it up. This is distilled deionized water, so you don't want to use tap water for this because tap water has all kinds of gunk in it. And it's a good idea to go ahead and add some water and then swirl it around. And particularly if the densities of the liquid and the water, so the original solution and the water are very different, then you want to add water and swirl to make sure it gets thoroughly mixed. So I'm just adding water to this. And once it gets close, you have to be a little more careful. And so we can use a eyedropper or something like that to bring the level exactly up even with the line. Almost there. Set it on a table to make sure that it's level, and I think one more drop will do it. Okay, so now again, the bottom of the meniscus is even with the line. Put the stopper in. If we're working with aqueous solutions, it's a good idea to put a little bit of grease here, because what I'm going to do is I'm going to turn it over to make sure it's fully mixed, and that little bit of grease is not going to contaminate the aqueous solution, but it'll keep liquid from leaking out past this thing. That's not super crucial. If you accidentally go over the line, you can't just start taking liquid back out. What you have to do is start all over. And so what we have here is a solution that is diluted from 20 milliliters of the red solution diluted up to 250 milliliters of total final volume.